The four main topics we're going to be talking about are what is hydraulic fracturing, what are the overall water requirements for fracking, because that's primarily where a lot of the concerns lie, is about the water usage and how the water is handled. The environmental considerations, that's all related to that water usage. And then a little bit on where prominent can help. We don't have a lot of details in that regard. This is primarily more about the fracking process, but there is some of this information about where prominent fits into the whole scheme of things. So I guess the first question is, what is shale gas? What you're going to hear is a lot of terminology thrown around, particularly in the press, about conventional and unconventional gas supplies. What I would recommend is when you're listening to somebody talking about conventional versus unconventional, think costs less versus costs more to produce. Conventional gas is typically gas that is accessible via a single drill. They drill a borehole down. They actually locate a pocket of natural gas that is naturally occurring in the Earth's crust. They go in and tap into that pocket, and they siphon that gas off that system. That may be a gas all on its own. That may be gas associated with an oil deposit somewhere. They may very well be sucking gas out of a coal bed methane as well. Coal bed methane tends to be a little bit more unconventional because it's a little bit harder to obtain and process. The unconventional gas tends to be the tight sand gases and what is now referred to as gas-rich shale, which is the Marcellus Shale, the other shale deposits that everybody's talking about these days. Again, it tends to be a more expensive process. It takes a little bit more time to get to it. It takes more materials, more manpower. It's a little bit more expensive to do. Ironically enough, when oil prices go up, processes like this become more and more lucrative because they can justify the additional cost to support it, to obtain those gases, because gas prices are justifying it. Hence the reason why OPEC gets so upset when the United States starts drilling for natural gas in our own backyard. We don't have to buy as much oil from them in some of those cases. What you're actually going to run into is a lot of cases, the shale gas is they're going to drill down to anywhere from 3,000 to 5,000 feet, and then they may actually have horizontal drilling an additional 10,000 feet. So there's a lot of support requirements that they have just to get into those formations that they're going to run into. The hydraulic fracturing is the actual processing of that rock formation so they can actually extract gases out of it. If you drill into a sandstone formation that has a certain amount of porosity to it, gases will tend to flow. A shale formation has layers of rock, and those layers of rock have a tendency to stop the flow of gas. So what they have to do is they actually have to go in and crack those rocks open and then keep them open so the gas can actually flow. To do that, they're pumping in material, water with some additives at pressures in the excess of 10,000 psi. So this is not a simple couple little pumps they're going to go into. They're going to go down very deep. They're going to pump into very high pressures. With the water, they're going to pump in a mixture of sand and some other chemicals. The sand actually works as what's called a proppant. So once those cracks are made, the sand goes into those cracks and holds them open and allows the gases to flow through that system. The press in many cases will talk about how this is this new process that's only been going on for the last few years. In fact, they've been hydraulically fracturing oil wells since the 1940s and 50s. Gas wells, not quite so long, but it's been going on for quite a long time. The technology in itself of hydraulically fracturing a rock formation is not new. It's been around for a very long time. Now what's actually going on is you're seeing a growth in that world because they're doing it in combination with a lot of horizontal drilling as well. They get down into a certain depth, they get into a shale formation, and then they can drill horizontally. In many cases, it's actually multiple legs. It's not a single run through a shale formation. It may be 7, 8, 10 legs that they'll do multiple runs into a shale formation to get as much access as they can. So here you'll see an actual kind of a diagram of how that whole process goes. At the surface, they've got the wellhead. They'll drill down into depths of 6,000, 7,000 feet. In the case of Marcellus Shale, they may be as deep as 7,000 feet in some of those cases. They will actually turn that drilling horizontally, penetrate out into the shale as far as they possibly can, and generally in multiple directions. And then what they ultimately do is down at the end of that wellhead casing, they'll actually use small amounts of explosives to blast small holes in their wellhead casings. Those holes give them access into the shale, and then once they do the fracking process, they start pumping in the water and the sand. It starts cracking that rock open. It gives those pathways for the gases to travel back up through the wellhead so they can collect it, take it off site, and ultimately process it and sell it. The overall process can take a fairly good amount of time for a well, but it's actually not particularly long in the grand scheme of things. A single fracking on a single well may be 3-4 weeks max, between the initial bringing of the fracking equipment on site on an already drilled well, to the fracturing process, to starting the downhole pumping of all of the sand and all of the proppant material, all of the chemicals, to actually getting it to be a productive well, maybe about 4 weeks. If you're actually drilling the well itself, add another 3 or 4 weeks on top of that. So in a span of about 8 weeks, you can actually have a producing well without much of a problem. Just to give you an idea of the economics behind this and what's driving this whole process. This is a little information I was able to get out of the Energy Institute, or the Energy Information Group in the U.S. government. This is strictly for the state of Pennsylvania over the last several years. And what you're going to see is the horizontal drilling really didn't take off until the beginning or in parts of 2008. A little bit of growth in 2009, and then it kind of exploded. So what you're seeing is initial drilling of wells went down, of actual drilling a single hole in the ground went down, but the horizontal drilling went up dramatically, starting in 2008, 2009. The net result is we actually drilled fewer wells in Pennsylvania, but we got about 6 times the amount of gas out of those wells. If you look at this from a perspective of a company trying to do this kind of work, they had to do less work overall, less drilling to obtain the same amount of product. Ironically enough, from the environmental aspect, fewer holes punched in the ground. So that you've had a little bit less environmental impact on the surface and got a lot more feedback out of that whole process. I saw some numbers here just the other day. Pennsylvania is on track to be the 3rd largest gas supplier in the United States, just behind Texas and Oklahoma, I believe. If the month continues the way it's been going, they may very well be the 2nd by the end of the month. So it's amazing what this process has done just for the area in Pennsylvania. Now, frac water, the water that actually goes down in the hole, is mostly just water. They add about 1% sand. It's usually a specialized sand that they use because they like to have a very particular arrangement on the grains. It works best if it's particularly round. And then there's about 0.5% of additives that goes into that process. Now, a lot of the big companies will talk about, well, we're not putting that much in the additives. There's only 0.5% of the overall water that goes in the well. But to frack a single well is anywhere between 2 to 5 million gallons of water. So if you figure a 3 million gallon frac water requirement, that's about 15,000 gallons of various additives that do go into the ground. Now, you've seen probably on the news of people complaining about fracking, and I actually saw a particular picture of one lady holding up a sign of how they were pumping benzene into our drinking water. I can tell you benzene is not part of any of the frac water combinations. It has absolutely no purpose. So again, the loudest voices are not always those that are getting out the best information. What I will tell you is the water is the biggest issue around the fracking. The water supply and disposal issues is really where a lot of the factors fall into this whole process. Also in the groundwater, which we'll get into a little bit in a few minutes here. One of the big issues is water use in drought areas. Because you're using such a large volume of water for an individual well, You can run into some problems in drought areas where water supplies are limited and you're in competition with agriculture. Agriculture still has a massively higher water demand than any frac water applications go, but you're still in a competition with them. So one of the issues that people will run into is where does that water come from? You're going to run into how do you get it to your site, all your trucking concerns. One of the most interesting things that's come up recently is some of the municipalities are benefiting from the fracking process. You'll have a municipal water complex that actually has excess capacity, that they don't need all of the water that they can process. They will process and sell off the excess to the frac water companies. So the municipality in itself makes money off of it. This is basically revenue for them, and they can use it to support additional infrastructure. The trucking concerns that you'll run into on a lot of these instances as well is you're running a lot of trucks to handle the amount of water on a frac site. Anywhere between 3,500 to 5,500 trucks per pad. That's a lot of trucks. That's a lot of traffic. It's going to take its toll on infrastructure. It's going to take its toll on diesel fuel. So if a producer is going to be looking at that and wanting to try to save himself some money, he'll find ways he can run fewer trucks if he possibly can. There's additional regulations that are going to be going on. One of the problems we've seen is fracking has come up so quickly that the regulations, the federal, state, local regulations around the water requirements have not been able to keep up. It's not unusual that you see a large business or a large business opportunity outpace the ability to regulate. And so the regulations will play the part of catch up here for a while until they can get around it. A lot of people will go in and reference to Safe Drinking Water Act and a few other regulations to try to apply them as best they can to the fracking water treatment requirements. One of the other big issues you run into is disposal of the water. I'll speak to that in here in just a second, but part of this is disposing water into deep wells. Some of the frac water cannot be reused, so it gets disposed of. It gets injected very deep into rock formations. Once it's injected, it's lost from the main water cycle. In drought areas, that's a big issue. So here's where recycling becomes a big issue. If you can recycle the water, you have much more advantage into how that process operates. I'll give you a perspective. This is one site that is in the process of being fracked. All of the big boxes on the perimeter of that site, each one of those is a frac water trailer. Each one of those holds about 20,000 gallons. So this is what they'll bring onto site to try to do this process. Now think about that. They're going to truck in every single one of those in the span of about 4 weeks. Think about the poor guy that lives in the house down in the bottom right-hand corner. They bring them in 24/7. Once you start a frac on a gas well, you do not stop until it's done. The guys basically work around the clock. They come in shifts. They run that process from start to finish. The benefit is when it's all done, they pick all that stuff up, they take it and they leave. They clear the pad off and they can actually remediate the pad without much of an issue and bring it back into a condition where the only thing left is a small building and the ability to pull gas off of that well from that point forward. But there's a lot of support requirements that go around fracking a single well. Again, we were talking about conventional versus unconventional. The reason this is unconventional is because it has got so much support requirement around it to get it to the point that they can actually pull the gas off the system. There's two different kinds of water that people deal with on the wastewater side of a fracked well. One is flowback water, which is basically the frack water that has gone downhole, done its job, and then is flowing back as the pressure in the well is pushing it back out of the well. You're roughly going to get back about 10 to 40% of injected water. It kind of depends on what the geology is that you're injecting into. If you have a lot of sandstone that's really thirsty, that's going to soak up some of that water around that shale, you may not get back very much. In some cases, some wells have seen returns as much as 80% of their frack water. It all depends on how that formation goes, and it's a little bit hard to predict it sometimes. You never quite know exactly what you're going to get back out of that system. There's also produced water. This is water that's naturally occurring in the formation that you're injecting into. So this water will keep coming out of that well for a long period of time. That well may be in service for 20 years. Once it's gone through this process, it may still be producing. And what typically happens is when the well is actually producing gas, it starts out producing a lot of gas and a little bit of water. And over time, they start to change positions. You start producing a lot more water than you do hydrocarbon out of that well. Over the life of the well, you'll get anywhere from 3 to 5 barrels of water for every barrel of hydrocarbon you get out of a well. With that, it's fairly safe to say most of these guys are not so much gas producers as they are water producers. Their main focus that they have to deal with is water. The gas is just the benefit of the entire process that they get going through it. Now, the flowback in the produced water that's coming out of the well can contain not only the materials that went down during the fracking process, but a lot of the natural materials that will come out of that water as well, including hazardous materials, arsenic, radium, uranium, other materials that are naturally occurring really, really deep in the ground. Radium is a big issue in Pennsylvania. You'll see arsenic in locations in New Mexico and Texas. Texas has uranium issues as well. These all have to be dealt with. So where you're running into the big issues around frac water is dealing with the water once it's out of the ground again. Again, you're dealing with a large quantity of water that you injected in and then you've returned back into the system. You've got to figure out what you're going to do with some of that water. The typical process for dealing with wastewater coming out of frac installations has been disposal into Class 3 saltwater disposal wells. These are wells that are about 1,000 to 2,000 feet deep, injected into what would be considered thirsty rock formations that will allow a lot of water to be added to them. The interesting thing is the state of Pennsylvania, which produces so much gas out of Marcellus Shale, has no Class 3 saltwater disposal wells. The geology will not support it. There's no rock formations we can inject to that will accept a large quantity of water. So what ultimately winds up happening is the state of Pennsylvania ships our wastewater, or has historically shipped wastewater, to Ohio, or even as far as Texas. There's a few instances where customers are actually going out and they'll produce that water, they'll get the wastewater, they'll truck it to a train depot, put it on train cars, and train it down to Texas because they have saltwater disposal wells that are suitable for their use. A producer who has the option between recycling water and paying all of those transportation costs is going to start leaning towards recycling. Consequently, recycling frac water is actually being led in a large part by what's going on in Pennsylvania. It's highly promoted in Pennsylvania. It's becoming more and more promoted in Texas. State of California has actually got to the point that they are going to require you use recycled frac water. You're not going to be given a choice. Again, this is where regulations are going to start driving a lot of what's going on in this industry. In the long run, recycling, if done in the right way, actually saves the producers a lot of money. They get to a lot of advantages by doing that recycling process. In a lot of ways, these recycling plants are set up so that they can give them exactly what they're looking for as far as the water that they need. The environmental impacts that you run into. We'll talk about the good first. Natural gas production. Natural gas burns substantially cleaner than coal and oil. It's a given. Coal and oil produce a lot of additional waste products that you're not going to run into out in the natural gas process when generating energy. Natural gas can also be processed into diesel fuel in a relatively simple process called a gas to liquids process. There's actually a gas to liquids plant being currently built in Louisiana by a company called Sasol. Shell is looking at a gas to liquids plant potentially being built in in Pennsylvania, probably out by Beaver, Butler, not too far from us. So there's some advantages to doing these kind of things because you can actually get some motor fuels done out of the natural gas process as well. The recycling of the frac water is becoming much more mainstream. It's much more accepted. as opposed to just trying to dispose of it. They're actually trying to find ways to reuse that water. There's a lot of financial advantages for the producers in a lot of ways. And the technologies are changing continuously, literally monthly. It was real interesting in the process of doing the research that if I pull an article or a paper that was written 2 or 3 years ago, the information in it was out of date. It was incredibly out of date. A lot of what we're finding is some of the contamination issues that occur, that people are talking about now, were issues that happened in 2008, 2009, when the process was still a little bit in its infancy. A lot of the processes have cleaned up in those few short years. So there's been a lot of improvements over the last few years. There's also a lower surface impact on the environment. If you look at the picture in the bottom right, it's an oil field shot, basically. So oil being produced, those are typically a single drill. They go down in the hole and they go straight down into an oil formation and they extract the oil out of that formation. So they may put dozens of pump jacks to get that oil out of that formation. A gas well with the horizontal drilling would have one point, one entry point, and then multiple legs way underground, so you're not going to see the surface impact. If you go out into West Texas where they do a lot of oil drilling, you'll see miles and miles of areas where you have nothing but pump jacks and well sites. Now the bad. There's always going to be a little bit of the balance between the good and the bad on each one of these. Treatment of the flowback and produced wastewater is always going to be an issue on these processes. There's actually new processes that people are trying to come up with that don't use water in the fracking process. They're actually looking to try to use hydrocarbons. The problem with that is the minimal return sometimes you get on the hydrocarbons. Remember I was saying when you go in and you pump in water into frack a system and you only get 10 to 40% back on your flowback. If you're pumping in a hydrocarbon, you're pumping in dollars. So the producers have a tough time thinking that I'm going to pump a hydrocarbon in and I'm going to lose 60% of that or more to get a different hydrocarbon out. They have a difficult time running with some of that processes. But there's newer and newer technologies that are being researched to try to improve on that process. A lot of the issues that come back in these deals as far as the water treatment is just improper disposal of waste. Some of the early frac processes, people were dumping directly into surface waters. And so they were dumping contaminated waste coming from deep underground into surface waters that would normally have those kind of waste going into them. Or they were sending their trucks full of frac water to a publicly owned treatment facility, wastewater plant that was not equipped to handle the high salt content, some of the radioactive materials. The plants just couldn't handle them. And in many cases, the plants would bring them in and literally not treat them. They would actually just pump them out into a river. There's actually been some evidence that the Allegheny River upstream of Pittsburgh is getting a high level of radium buildup in the silt. And they're attributing a lot of that to the frac water treatment and the water that was discharged into the Allegheny early in the process of fracking growing up in the Marcellus Shale. You'll see induced seismic issues. In other words, man-made earthquakes. There are somewhere in the ballpark of 35,000 fracked gas wells in the United States. Of all of those, there's only one that has any indication that there was a seismic activity associated with the fracking of a well. And when they indicate seismic activity, it was actually seismic activity that was measurable on instrumentation, but not something that you could actually feel. So they were actually picking up a little bit of seismic activity, but they couldn't even point for sure that it was actually going on from the fracking. Now, on the saltwater disposal wells, there has been documented evidence of man-made earthquakes because of overfilling on the saltwater disposal well. One instance in Ohio, one in Texas, one in Arkansas. There's some possibilities in Oklahoma as well. The good news is on those is as soon as it's been measured and those well sites were stopped, no more injection into those formations, the seismic activity stopped. So it's one of those where you can actually identify it say, yes, this is the problem we're running into, and they can actually put a stop to it. The other issues that run into a lot of the stuff that you're dealing with on the bad side of the environmental impacts, the groundwater contamination, which I'll get to in just a moment, and stress on the infrastructure. You're running a lot of trucks. You've got a lot of those issues that you've got going on, so you've got to support all of that. And those are the problems that people are going to run into. The environmental impacts. There have been literally hundreds, probably thousands of cases presented. In a great majority of those cases, the evidence doesn't support what's being claimed. There have been a few instances where they found frac water materials in drinking water. In most cases, it was not from the frac water getting into the drinking water process from the well itself. In many cases, those were runoff issues where the frac water was they'd get a rain event, they'd wash off material from the well site, and it would find its way into the watershed. Not uncommon, and mostly it was due to poor handling on the well site itself. But it was not coming directly from the well. You'll see the diagram on the right. When they do a gas well, they do multiple layers in the gas well. The first two layers are primarily there to protect against contaminating anything around that system. It's also there to protect them from getting any water in their well. Any more water that comes into their gas well is water they have to treat. So they have some reason to not want to have any cross-contamination between the groundwater and their actual well. In most cases, the producers also have a lot of interest in the not contaminating the groundwater because they know the litigation can be one of the most expensive processes in their whole business. So they do try to avoid it as much as they possibly can. A couple instances where I've seen some extreme reactions to suspected groundwater contamination. Once I did a little bit of digging, I found out some really interesting things. You may have seen a news report that came out of Texas for natural gas contamination of drinking water in a well. And the news report actually showed a woman standing by her tap in her kitchen, water pouring out, and she'd stick her a lit match underneath the faucet, and flames would leap out of the piping. And quite honestly, she had natural gas in her well. They were blaming it on a fracking installation that was about a half a mile away. This was done in, I believe, about 2011, if I remember correctly. It went to court. There was a great number of quick reactions by government bodies that said they need to limit what they're doing, they need to stop what they're working on, they need to remediate. Ironically enough, they had a government agency tell the drilling company they need to remediate the Trinity Aquifer, which covers about a third of the state of Texas. So how you remediate something the size of a third of the Texas is beyond me. When they actually did the due diligence and they dug into what was going on, they found out this well had gas in it as early as 1998. The drilling company that had done the fracking of the local well drilled it in 2009. So as early as 10 years prior, those water wells had gas in them. What they're finding is, in the case of that installation, the water well driller drilled too deep. He actually drilled into a coal formation that was right underneath their aquifer. And they were pulling gas off of the coal formation. They were able to establish this very clearly. Now, it's not to say you won't every once in a while have instances where there's going to be natural gas occurring and showing up in groundwater. If a well is not done correctly, if it's not cased correctly, there's always those chances, those potentials. But it is not nearly the crisis that Hollywood and the press and some of those other things can have a tendency to overemphasize. In a lot of cases, what's happening is those failures are because of substandard operators. Companies that don't have the general public interest in mind. They're more in the mind of the only thing they're going to do is make money off of this while they can. Where Prominent can help. The seminar I was able to attend was actually attended as well by multiple chemical vendors. GE, Nalco, and US Peroxide all had representatives there. There's a lot of opportunities for those guys because they sell various chemical products that go into the frac water process, or they're selling equipment into processes that help treat the water once it's come out of those systems. OEM suppliers supporting the frac business, companies that are supplying packaged equipment to treat on site. This would be some of the chemical feed equipment that's going into setting up the frac water. Most of the frac water formulations are done on site because they are time sensitive. They cannot be made off site and trucked in. They need to be made on site and combined on site. But I think one of the most interesting for us in a lot of ways are the dedicated frac water treatment facilities. There's a couple companies, particularly in Pennsylvania, but they're showing up in other parts of the country. They are building facilities that are specific to treating oil and gas wastewater. So they have the provision to take care of the oily waters, the dealing with some of the radioactive materials that come in. They're dedicated to these installations. Reserve Environmental Service in New Stanton actually bought the old, I want to say Sony. It was an old Sony facility that had been mothballed. They bought the facility simply because Sony had a very large water treatment plant on site. They rebuilt the water treatment plant, dedicated it to wastewater treatment of oil and gas, and are now basically custom treating water for oil and gas producers. An oil and gas wastewater truck can pull up to their plant, offload their water, pull around to the other side of the plant, and actually have a very specific outline of what they're looking for as far as treated water. What they're finding in a lot of cases in frac water is you don't have to clean the water up to a very high quality. You can bring it to a basically what would be a minimal recyclable quantity, and it's actually a benefit because they truck that back out to the site and they have to put fewer chemicals back into that water to make it usable. And so not only is the recycling saving the water, but it's actually saving the producers money because they don't have to spend as much money on putting new chemicals into the process. The company in New Stanton has got one full facility built. They have another facility almost ready to finish. They have another facility in the planning stages, and they're looking at it potentially 2 or 3 more in either Ohio or West Virginia. This is going to be a growing business. Eureka Resources out of Williamsport has a complete facility. They've got 2 more on the books as well. And those are just 2 companies that I did a little bit of research on. There's dozens others. And these are all organizations that are looking at treating the water to minimize any additional environmental impact. The RES organization, actually, their main facility is a zero discharge facility. They don't discharge anything. They don't discharge any wastewater. Major improvement over some of the previous things that were going on just 3 or 4 years ago. More than anything, this whole process is we're going to look for find other people to help. This industry, as it grows, creates jobs. We've actually seen a few instances where the drilling companies and the companies dealing with fracking of gas wells have gone out and found where coal workers are being run out of business, getting them retrained so they can actually work well sites. To be honest with you, if I was a guy that had been working in coal mines for years and I had an opportunity to work above ground for a while and not breathe coal dust, I'd jump all over it. A lot greater opportunities, much better for your health, not contributing to a lot of air pollution issues as well. So. And then the future. This is just a single map showing the North America shale plays. These are shale formations that are known good producers of natural gas. You can see Marcellus Shale up in the Northeast is a huge formation. That's already being played on pretty well. Eagle Ford down in Texas is huge right now. It's producing a lot of gas. It's making it difficult for OPEC to look at Texas and not be a little nervous that they're going to be outproduced with hydrocarbons here pretty soon. Bakken Shale up in the northern part of the United States, southern part of Canada, That is producing a large quantity of gas as well. But there's so many other formations that still have a lot of opportunity too. So this is not going to go away anytime soon. One of the biggest plays that people are talking about right now is Monterey in California. Geographically, it looks like a much smaller play, but the geology supports that Monterey could very well carry more gas than Marcellus does. Now, California, we all know, is driven by regulation. And in many regards, California is in a great opportunity because they get to learn from what's gone on in Pennsylvania and Texas up to this point. They've already started putting regulations in place to kind of control how this process goes. But California as a state has looked at this and said, this might be our way out of bankruptcy. This might be our way of not running into the debt issues that we've had for a long period of time. So there's some advantages on the political side as well to going down this route. Now, this map only shows North America. There's a couple other maps that I've had that show Europe and Asia and South America, all with comparable shale plays. China is huge on this right now. China is suffering from massive amounts of air pollution because of all the coal-fired power plants they use. And they know that if they go to gas, they can save themselves a lot of grief just on the air pollution alone. So again, this process is not going to go away. A lot of the other people out in the world are going to be benefiting from all of the pioneering work that's going on in the U.S. right now.